Okay, so let's go ahead and get started on that. So let's talk about vapor pressure of a liquid. Vapor pressure of a liquid. So first thing we're talking about is hydraulic system. So does anybody know where a hydraulic system is used? Give me an example where a hydraulic system is used.
An airplane.
What?
An airplane's wings.
Airplanes, yes, airplanes. Okay, airplanes. We have a hydraulic pressure, right? Where else?
The clutch in a manual transmission car.
Yeah,
is
so you're
hydraulic.
right? You have a hydraulic. When you do the hydraulics, you can use your clutch when you're using a clutch, right? Okay, all right, good. Okay, some of the examples that we use in the book, I think it's that they do the hydraulic jack, right? Hydraulic jack when you go to a garage or where you're trying to fix your car, they want to get under it, they put your car on a jack and they lift it up type of thing, right? Okay, so that's also done by hydraulics. And the basic reason that why we use hydraulics, what is the substance that is used in hydraulics? Usually it's what? It's oil, right? Hydraulic oil, right? It's a hydraulic oil system, right? Okay. And it's basically because it's not compressible, right? So, I mean, it does not, when you compress it, it doesn't deform, it just transfers the pressure back and forth, okay? So let's look at that figure on page 323 on the bottom. It shows you a system of something that looks like this, right? You have this, and you're going to have a piston in here where you can actually, so this is the 3D version. Let me go ahead and draw you the 2D version. The 2D version would look like this, right? So you are pressing, you have a piston here. We're going to push this, and you have a piston on the other side. And the piston, when you push this in, is going to move because you're compressing the gas or the fluid over whatever's in here, right? So if you move this guy is going to move also. Okay, so the difference is that you have a radius, a smaller radius here, and a larger radius here. And they're calling the cross-sectional area here A1. The cross-section area here is going to be A2. And you're going to move it a distance of L1. And this one's going to move accordingly a distance of L2. They're not going to move the same distance, correct? And so the question is, what is the difference in the distance, right? If I move this L1, how much am I going to move this L2? Okay. So the force that you put in here is going to be transferred to a force here. So the force, this is the situation where you have where the pressure, because the pressure in here in that system is going to be the same. The pressure at here, P1, is the same as the pressure over here, which is P2. So this will be P1. This will be P2, right? Because pressure is force divided by the area, right? So we have force divided by area, force divided by the area, right? So this is what we're going to use. And we're going to be able to say from here that the force that is felt over here on this piston is going to be equal to A2 over A1 F1. Okay, just using this relationship here. Okay, if you flip the page, it's going to tell you that the volume, so the volume that you displaced here is going to be the same as the volume that you displaced over here. Okay, so the volume here, right, if you look at that cylinder here, the amount of cylinder fluid that you moved over here, that's going to be L1 times A1. Okay, and that's going to be the same as L2 A2 over here. So it's going to be L2A2. Okay. So L2 is going to be equal to A2 over A1 L1. So when we talked about what is the displacement going to be here when you move this, when you displace this L1, this is how you would find that. Okay. One last thing here that is we can say is that since this is L, the displacement, I can divide both sides by time t. What that creates is, now this is the amount of distance it traveled during that time. So that is going to be what? Isn't that basically velocity, right? Time divided, the distance displaced divided by a time, right? Okay. So this is going to be V2, or velocity 2 is going to be equal to A2 over A1, velocity 1, okay? So when you look at that equation on the bottom, middle of page 324, do not mistake that with the volume. That is not the volume, that is the velocity, okay? If you look on the bottom of page 324, it gives you a simplified version of a hydraulic jack, okay? So there are two drawings there. The one on the left is the actual how an hydraulic jack works, okay? And the one on the right is it took it out and it kind of expanded it and it shows you what was going on there, right? So if you look at that diagram, right, you have a pump or a lever where if you press it down, it displaces the hydraulic oil that is in the reservoir and it pushes it up, and that basically lifts the load. So the load gets lifted as you pump it, as you jack it up, right? Until when you want to bring it back down. And the way you bring it back down is by the release valve or the relief valve, okay, whichever one they call it there. It's the release valve on the left and the relief valve on the right. Well, that's kind of nice. So they're the same thing, right? Basically, it's a little spigot or something where you release, press a button and it releases the pressure, and the hydraulic fluid that was in there that was holding up the load now gets to go back to the reservoir and it drops the load, okay? Depending on how quickly you release it, that also kind of controls how fast the load comes down too, right? Okay, so that's how a hydraulic jack works. Let's go to example 1012 on page 325 and do that example together. It says, determine the load that can be lifted by the hydraulic system shown, and if you're going to be using, okay, so we have a hydraulic system where, and on one side we have a load, on the other side we have a different load here, so we have M1 and M2 here, different masses, right? And we're going to have M1 is 100 kilograms, M2, that's what we're trying to find. This is what we're trying to find. We're trying to find M2, and we have R1 is equal to 5 centimeters. R2 is going to be equal to 15 centimeters. Okay. So the force generated by M1 is going to be F is equal to F1 is going to be equal to M1 times G, the gravitational constant, right? And this over here, F2 is going to be equal to M2 G. Okay, so the equation that we were using was F1 over A1 is equal to F2 over A2. Okay, so, and we're trying to find F2. So F2 is going to be equal to A2 over A1 F1. Okay, where A2 is the area of this guy with the radius of this. So it's going to be pi r squared. And over here, we're going to have A1, which is pi r squared. F1 is going to be m times g, right? So it's going to be 100 kilograms, 100 9.81, right? Actually, I'm not even gonna, you shouldn't even do the G, because F2 is gonna be equal to what? F2 is gonna be equal to M2G, right? And the G's are gonna cancel out anyway. So we get what? Pi's cancel out. We have 75, not 75. 15 squared is 225 divided by 25, 100. So this is M2. This is all we have left. So this is going to be 9 times 100, 900. Okay. So if I have 100 kilograms here, the most that I can go is 900 kilograms. And if you think about it, it makes sense. So it's 9 times, right? And where did the 9 come from? That's the difference. If you look at the R difference, it's a 3 times, right? So the radius over here is 3 times the radius there. Since the area is pi r squared, it's 3 times the R1. So if you square that, it's going to be 9 times. Hence, the 9 times right there. Okay, all right, so that's how you would run that. And then we have the modulus of elasticity, modulus of rigidity, and bulk modulus of compressibility. Okay, it's pretty fun reading. So if you want to go to page 329, there's the Hooke's law of the springs. Oh, no, this is where the stress. So we have the normal stress is going to be equal to the modulus of elasticity times the normal strain. That's on 10.24. Then it goes ahead and develops the equation where E is equal to FL divided by AX. So it's a nice, again, you know, I wouldn't worry too much about it unless you are going to, but you do need to know this. I mean, you know, mostly used by mechanical engineers. So that's it. Let's go ahead and actually do some work. Let's have you do some homework first and see if you guys can work on those and get that done. Let me see, where are we at? 10.5. Did I